Let's try subtraction of two fractions. This time we're going to have like denominators. So we have 5x plus 5 all over 2x minus 4. Subtract 3x plus 9 over 2x minus 4. You'll remember from arithmetic, when we have like denominators, we keep the denominator, 2x minus 4, and we subtract the numerator. So we're going to have 5x plus 5, the first numerator, subtract from it the quantity, 3x plus 9. Let's perform that subtraction. That is going to be 5x plus 5 minus 3x minus 9 all over 2x minus 4. Simplifying the numerator, we're going to get 2x, 5 minus 9 is minus 4. And we so happen to have a numerator and denominator exactly alike. I don't want you to think of canceling the x terms and then canceling the number terms. That's incorrect thinking. Put a parentheses around each binomial. The quantity, the parentheses of the numerator cancels the parentheses of the denominator, giving me an answer of 1. That is proper thinking. Okay, our next problem is also subtraction. We have a cubed over a minus 3. Subtract 4 over 3 minus a. I'm observing that the denominators are exactly opposite. Therefore, my thinking goes like this. Within the denominator, I'm going to extract a minus 1. So it's minus 1 understood, a minus 3. That does distribute out to the original denominator, keeping that as a 4. Now, this minus sign along with this minus sign can change it from a subtraction problem to an addition problem. So I want to add, because I have a subtracting of a negative quantity, I want to add this to this. And because we have like denominators, I'm going to keep the denominator, a minus 3, and I'm going to add the numerators. I have no way of factoring that numerator, and I'm not allowed to cancel just the a parts or the numerical parts. This is the final answer to the problem. Where would this fraction be undefined? It'd be undefined if this denominator were equal to 0, and the denominator would be equal to 0 if a were equal to 3. And for our last problem, let's subtract fractions with different denominators. So x minus 6 over x plus 4 minus x plus 3 all over x. We cannot subtract when we have unlike denominators. We need an LCD. An LCD, in this case, is just a product of the two denominators. That is the least common denominator. Changing this fraction into the LCD of x times x plus 4 means I need to multiply the numerator by x. And to change this fraction into to have a denominator of x times x plus 4, I need to multiply its numerator by x plus 4. To subtract now, we keep the denominator, which is x times x plus 4, and we want to multiply out the numerators and then finally subtract. So I'm going to have x squared minus 6x minus parentheses x squared plus 4x plus 3x plus 12, which does consolidate down to x squared plus 7x plus 12. But now we need to subtract. So it's going to be x squared minus 6x minus these three terms. So it's minus x squared minus 7x minus 12 all over x times x plus 4. The x squares cancel. Minus 6x and minus 7x gives me minus 13x. Minus 12 all over x times x plus 4. There's not much I can do with that. It doesn't reduce. The only thing, if you wanted to, you can extract the minus sign from the numerator and say it's minus. The numerator would become 13x plus 12 all over x times x plus 4. Either way is correct. I'm just showing you a variation of the answer. That's all, folks.